Good day yet again, friends. We are back together. All right, your favorite uncle is yet again with you. All right, so we are looking at electrostatics now. Right, if you haven't subscribed, please just do the right thing. All right, let's get right into it. We are given 2 point charges there. Okay, that's P and T that are placed 0.03 meters apart, and the charge on P is 36, positive 36 times 10 minus 6, okay, whilst T carries a charge of 16, right, of unknown sign. Now they say to us, state Coulomb's law in words, right? Remember, we say that the electrostatic force between 2 point charges, right, is directly proportional to the magnitude of the charges and inversely proportional to the square of their distance apart. Okay, right. So they say draw the electric field pattern around a positive charge. All right, now we're going to do that. Okay, so for 7.2, what we're going to do is we're going to draw that positive charge. Okay, and please remember, for a positive charge, what we will always have is that the field lines would be moving outside. Okay, so they are our field lines. Please, when you draw those field lines, ladies and gents, please make it a point. Let me just undo that. Please make it a point that the lines do not cross each other. Okay, so that's very important, and that they touch the circle. All right, so we must make sure that they don't cross each other and they also touch that circle. All right, so there are our field lines. We're going to show that the direction will be outside or away from that charge. All right, so that is what a positive charge looks like. Okay, now they say to us, when a test charge is placed at point X, right? Oh no, actually, I think I might have skipped a question. They say calculate the magnitude of the force that charges P and T exert on each other. Right, what we will not know is the nature of the force, but there's nothing wrong with calculating that force there. Right, so that's F is equals to KQ 1. Okay, so let's say QP and QT, right? That's QT divided by R squared. So that's going to be 9 exponent 9 times the charge on P is 36 minus 6, and the charge on T is 16. And they said they are at distance 0.03 meters apart, right? Please don't forget to square that distance. All right, so let's calculate quickly. So this is going to be 9 exponent 9 multiplied by 36 exponent minus 6 and multiplied by 16 exponent minus 6. Okay, and we get a value there, and we divide that by 0.03 squared. Okay, I get a force of 5,760 newtons. All right, please verify it for me and let me know if you get the same answer. All right, so we don't know whether it will be a force of attraction or repulsion because we do not know the charge, whether T is actually positive or negative. Okay, right, but nonetheless, that is the magnitude of the force. Now, they say when a test charge is placed on X, a distance R meters to the right, okay, on charge T, as shown in the diagram, the charge remains stationary. Now let's talk about that. Now remember, every time that we place a test charge, we always assume that that test charge is positive, right? Now, what is charge P going to do to the test charge? Charge P is going to push the test charge away, right? Remember, if it's positive, it means they will repel each other, but we assume that it is the test charge that actually would experience that force. So it would experience a force in that direction. So the field due to P will be to the right, okay, because it's positive. Now, in order for that test charge to remain stationary, right, it means in this case the other force has to be in the opposing direction, right? So it's a positive test charge, so T in this case has to be negative. Can you see that? Right? In order for it to experience a force in that direction. Okay, so that means that T has to be a negative charge in that regard, right? So they say to us, write down the sign of charge, of the charge, positive or negative of T, and explain the answer. Right, so definitely we've said that T has to be negative, right? Right, so and the explanation of the answer, if the net charge or the net force is rather the net force has to be 0. Okay, let me just put that there. Okay, so for 7.4 we're going to say our answer is negative there, right? And number 1, the test charge experiences a net charge, or a net field rather, of 0. Okay, experiences a net field net field or net force of 0. Hence it remains stationary, right? It remains rather, so that remains stationary, right? The force on the force due to P is to the right, therefore the force to Q due to T rather, the force due to P to T, okay, to T has to be to the right as well. I mean, has to be to the left. And therefore T has to be negative. All right, I hope that makes sense. All right, I would wish that, when they ask us these questions, they give some kind of indication in terms of the keywords, right? All right, now they say to us we need to calculate the distance R. All right, so what we are going to do, ladies and gents, remember we are talking about a test charge, right? So let's take those two. We've got P and T. We know that's 36 times 10 to the minus 6. This is 16. Now we know it's negative. Okay, both of them. And here is our point charge. Actually, let's use a different color, right? So in this case, what we are going to do is calculate the field due to T, right? So due to T, and this is P. Right, now let's do so separately, and we're going to talk about that later on. Right, so the field due to P, that's going to be K QP over R squared. Okay, so that's 9 exponent 9, and the charge is 36 times 10 minus 6 divided by. Now I want you to please note, we know the distance between P and T is 0.03, right? But what we did not know was the distance between T and the point charge, and we named it R, right? So keep that in mind. Okay, so which means the distance between P and the point charge should be 0.03 plus R. So this will be 0.03 plus R squared. Okay, right. So now that's the expression for the field due to P. There's nothing much we can do there, right? But what about the field due to T? Right, we're going to do exactly the same thing. 9 exponent 9 KQT over R squared, and that's 9 exponent 9 times the charge, which is 16 negative 6 divided by divided by R squared. We don't know what the distance is there, so we're going to say divide that by R squared. But what do we know? We said in this case it would remain stationary. So what does it mean? It means that the two fields, right, EP minus ET would actually give us 0. And so what does it mean? It means that EP is equal to ET. So I'm going to put those expressions there. 9 exponent 9 multiplied by 16, right? 36 times 10 minus 6 over 0.03 plus R squared. And this would be equal to exactly the same, 9 exponent 9 multiplied by 16, okay, minus 6 divided by R squared. Now, ladies and gents, let's try and, get rid of what we can here. If we divide both sides by 9 exponent 9, right, this will cancel, that will cancel, right? I can divide by times 10 minus 6 times 10 minus 6. Okay, so I'm left with two things there, 16 and 36. Okay, so those ones I can actually keep, right? So that means 36. Now if I cross multiply, 36R squared will be equal to 16 times 0.03 plus R all squared. Now, ladies and gents, I'm not going to waste time here, right? Can you see that both of these on the left and on the right, both of them are perfect squares, right? So I'm just simply going to take the square root on either side. Remember what I do on the left, I do on the right. Okay, this will make it easier for us to solve. Okay, so I'm going to take the square root of 36 is 6. So I'm going to have 6R. And I'm not going to bother myself with plus or minus because, of course, we cannot have a negative distance there, right? So 6R would be equal to 4 into 0.03 plus R. Okay, right, so we've got 6R is equal to, so 4 times 0.03 believe this would be 0.12, okay, plus 4r, okay. If we take the r to the other side, 4r to the other side, 4r minus 6r minus 4r will give us 2r, and which is equal to 0.12. And if we divide both sides by 2 there, okay, r will be equal to 0.06 meters. All right, I hope you get the same answer. If you don't, please just put that on the comment section. Okay, right, and this is essentially how the cookie crumbles, guys, and I hope that this makes sense. All right, and there goes electrostatics, and I'll see you guys again next time. Sharp, sharp.